All right, AP Stat students. Obviously, I'm not here today. This is August 28th, 2023. And in my absence, you're going to be able to still get a lesson today. And we're going to be talking about doing and creating the variety of graphs that go with quantitative data. Okay. So let's go ahead and get into it. And hopefully, you enjoy my little intro. Here it is. So there it is in your notes. Go ahead and let's title it with this right here, 1.2, displaying quantitative data with graphs. So you can go ahead and we can pause the video. Everybody can write that down and then start the video again. So if you don't already have a TI Inspire ready to go, I would recommend that we pause right now and also go grab one of those because we're going to be learning how to make all these different graphs, these quantitative data graphs inside of our TI Inspire. Also, if we need to pause a little bit more, have out a laptop as well, and you can have My Open Math with this as well. So if we need to do a full pause to grab all those things, let's go ahead and do that. But without any further ado, we're going to go ahead and get started. Okay. So in your notes, we've titled it Displaying Quantitative Data with Graphs. Let's put a little star. And the first definition that we're going to write is this one right here. This is the dot plot. Okay. And we can pause, but I'll go ahead and say it. Each data value is shown as a dot above its location on a number line. And of course, how we can make one of these, you do not need to write that. We are going to have a computer always make these for us. That's going to be our goal. But let's pause the video and make sure everybody's got this written. Okay, so we've got that. Let's go ahead and start creating a dot plot. They're very, this is one of the simplest plots that you could ever create. So let's go ahead and see what that looks like on the TI Inspire. For our example, as we start working through this, you can go ahead and on your laptops have open My Open Math, this unit's problem set here. And we're going to be on question 23. So as I'm talking, you can go ahead and get to that one. And you'll notice that this one is actually going to be talking about a histogram, which we'll get to in a second. But we are going to go through the steps to get this same data in our Inspire, and we're going to make a dot plot first. Then we'll turn it into a histogram. Okay. So let's go through the steps of that, and I'm going to go very slow. And I beg you, if you feel like you missed a step, ask whoever's sort of running the video to hit the space bar to pause it, just so that you can catch up. Or if you need to rewind, use the left arrow key to go back 10 seconds. I trust that you will all be professional about dealing with that. So let's go ahead and go through the steps. So first, make sure that you are on the home page. You hit the on button. I've highlighted that red on the screen, and we're going to go to new document. Okay. So we go over here to this new document button and hit OK. And we want a list and spreadsheet. Okay. A list and spreadsheet. Now, on our problem set, it says it is a researcher gathered data on hours of video games played by school-age children and young adults. She collected the following data. Okay, so these are hours of times played in video games. Now, you have, whenever you come into your Inspire's spreadsheet system, you have to go up to this first row up here. These are your column names, the column variable names. Now, we could name this X and just call it a day. We can name it hours. We can abbreviate the word hours. We could put time in here. You on a test or the AP test or anything get to just do whatever you want. So if I put, but you have to name it. So don't forget that it has to be named. So we could put X in here. I'm not going to do that. I'm going to type hours in here just so we have the context, and then you can hit enter and it takes you down to this page here, or this here, which we'll talk about later on, but we don't need it right now. What we're going to do is we are going to you can pause the video. I think everyone has their own set of data, which is fine. If you want to type your data in, you can. Whoops, I'm going to make mine a little bit larger here. Okay. So if you want to type your own data in, I would recommend doing that. Or you can do just like me on this one. and you can practice with my example. Now, I'm going to go ahead and skip ahead in the video and to where I've gotten this typed in, so you guys don't have to see me do that. But if whoever's controlling the video, if you want to pause it and let everybody have time to type theirs in, that would be great. All right, so all my data is typed in. There are 38 on my data set. I don't know if you have more than that, less than that, because it looks like it only goes up to 40. But I've typed in all my values, and we're going to go all the way back up to the very beginning up here. And so hopefully everybody's got theirs. If you need to pause again, if somebody's behind, let's pause and wait for them. It's A-okay. If we're ready, let's go ahead and graph our dot plot. If you want to write these steps down, like on your notes, you can put Inspire steps, and step 1, type in the data, right? Or step 1 really is list in spreadsheet. Step 2, type in the data, name the variable column. And now step 3, we want to make the dot plot. So we're going to press menu. And we're going to go to data. And we are going to do summary plot. And our X list, actually, as a matter of fact, I've done this incorrect, and I'm not going to go back and edit this video. So let's actually do it a different way. I'm so sorry, guys. Here's what you're going to do. You're going to press the yellow button, Control, and then we are going to click the Add Plus page. It's the dock button, but you'll see it right below the On button, right above the dock button, the page. So let's just add a new page. That's actually what we need to do. Sorry about that. All right, so we have a new page added, and I'm going to zoom in on this so we can really see what's going on here. So last pages that we added were list and spreadsheet, but we really want this one now to graph our graph. We're going to do add data and statistics. So let's go ahead and click that. Okay, now you're going to see on here all kinds of dots. Oops, sorry about that. I'm going to move my camera out of the way here so you can see this a little better. We see all these dots on here. Now, this part of your calculator is a touchpad. I think I talked about that in class last week. But go ahead and use your finger and brush your finger on the touchpad, and it will move the mouse around. And we need to go down to the x-axis, and that's where we're going to assign our x variable. So you're going to click there, press in with that center click button, and then you're going to click hours, and watch that. The points jump around, and it's quite satisfying to see that. We don't get to see that in Staplet, actually, so I always enjoy that. Now, if you want to see that again, if you say you want to undo that, you can always press the yellow button and the letter Z. It undoes things, just like a computer. Control Z is undo. Now, if you want to redo something, you press Control and then the letter Y. Did you know that? Yes, redo is Control Y, undo is Control Z. These are cool things to know for computers. But here we have our dot plot. That's not what the question asked us to do, but when we think about our definition, this is the simplest graph, one of the simplest graphs to construct, and it just gives us an overall view of the graph itself. Okay, so before we go on to really answering this question here, we want to talk about not just how we graph these things, but how we analyze them. That's going to be very important, especially when we get down to some of these other questions down here, like this one here, number 25, where we have to describe a distribution using these terms right here. So that's what we're going to go ahead and talk about actually right now before we come back and actually do this problem. Okay, so in your notes, I would like you to I would love for you to draw a little star like we usually do underneath where you have dot plot and your little instructions. And we're going to click how to examine the distribution of a quantitative variable. Okay. And maybe this won't make sense today. I'm sort of working with what I have. I'll be able to provide a better example on Tuesday for you guys. But we're going to go ahead and start with these ideas. Okay. So number 1, look for the overall pattern and for striking departures from that pattern. Now, we don't have to pause just yet. I'm going to go ahead and show the next 2. There's 3 things here that we're going to write down. But when we are interpreting, we look for an overall pattern and striking departures from that pattern. How we kind of do this is really what 2 and 3 are talking about. So first off, 2, when we look at the overall pattern, we're interested in its shape, center, and spread. So there's going to be some important things that we're going to discuss in this week as a whole. And we'll see how far we get in this lesson. I may just stop at shape for now, and we'll go from there so that we can do a couple of our problems on our my open math. But the last part is we want to note individual values that fall outside of the pattern. Okay, so that's really what's up. Overall pattern and departure. So this is what we call outliers. Now, I think we've already said the word outlier in our class before. But now we're really actually like taking a formal definition to it here. Okay, so outliers are we're going to be more aware of what an outlier is when we're discussing the shape of a distribution. So if we need to pause and get all this written, let's do that. And then when everybody's done, we'll just continue the lesson. All right, I know this class is the class of writing, and so we're going to go ahead and what I would have you do is hold on, let me go back to this. Let's actually, where it says how to examine here, I know the dot plot section was small, but let's put a line. I always enjoy making lines in our notes between the dot plot and where we wrote this, how to examine the distribution of a quantitative variable. Okay. Because it really should get its own section if you have to go back and look at stuff like this. So underneath how to do this, we're going to talk about describing shape. So at the top here, we have describing shape. That's something you can put a star beside because we need to know how to describe the shape of the graphs. So we're looking for what's called rough symmetry or clear skewness. That's really going to be the way that you're describing a graph. Okay. And so I'm about to put a bunch of words up on the screen. Okay. And yes, you're going to need to write them one at a time. And so we'll have whoever's running this pause so that you can write it. And I'm just going to put it up and then we'll talk through each one. That's what's going to happen. So here they are. So here are the three. There's actually four main ways. We'll add the next one in a second. There's four main ways to describe a distribution. Here are three of the most popular ones that you're going to see. You have symmetric, skewed to the right, and skewed to the left. Okay. So let's pause the video now and take a moment to get all of this written. Okay, so hopefully you've had time to write these down. At the bottom of the screen, we have three distributions. Okay, three distributions. And you need to decide on your own right now, and we'll pause, just so that everybody can try this. Based on what you have above, symmetric, skewed right, and skewed left, what would you identify the left, middle, and right graphs that you see on the screen right now? Okay. So we've written down those definitions and now we've interpreted those. So go ahead and let's pause the video and you guys think on your own, what would you assign to each graph? All right, now that you've had time to think about it yourself, go ahead. We're going to pause the video once again. See if you agree with your neighbors. That's what I'd like you to do. So let's pause it again, just so you can discuss real quick. Okay, is this one skewed left, skewed right, symmetric? And then, of course, I'll reveal the answers just to see how we did. So go ahead and pause the video and discuss with your neighbor. All right, so let's go ahead and reveal these. I don't know if they all show up at the same time, but let's see here. So the first one is symmetric. Now, it's important to use the word roughly symmetric. Symmetric implies like perfect symmetry, and that's very rare to actually occur. So I prefer this one to be called roughly symmetric. Okay, let's just go ahead and reveal the next two. Okay, skewed left and skewed to the right. Now, these definitions, sometimes students really get confused. Okay. But let's think about this. Look at the definition, skewed to the right. The right side of the graph containing half the observations with larger values is much longer than the left side. So the right side is much longer than the left side. Okay, maybe that still doesn't make any sense. Let's look at the middle one, skewed to the left. If the left side of the graph is much longer than the right side. Okay, so let's let me show you a different way to look at this so that maybe it makes more sense if it isn't making sense, which I'm sure there's some people in the room where it's like, oh, this does not make any sense at all. So let me draw on this picture. Okay, so I'm going to grab a little drawing tool here. So really what I always tell my students, and I'll reemphasize this on Tuesday, you have to imagine like you're taking a bed sheet and like throwing it on top of these. So for instance, and we'll see how I do with the mouse on this, we're like dropping a sheet over this, okay? And so for an instance, you don't even look at the dots. We just sort of fill this in and we look at it and we look, okay, well, inside of here, if I were to split this down the middle, let me add, oh goodness, a ruler here. I don't even know how to use this. Hold on. Can I turn this here? We're getting rid of the ruler. If I can insert a shape here, let's do this. This guy will, no. Well, this is going great. Draw, click. Okay. If I'm able to grab this and move it down. So if I were to say, okay, where's the center of this? Okay, we would say about here. Okay. And so when we look on the left and right side of that, I don't know if everybody can see that very clearly. Let me make that, instead of blue, let's make it, is yellow good? Yellow's not great. Is this dark blue any good? That seems okay. So on this, the center right here, the left and the right sides of this graph look about the same, okay? And so then if I continue this, we drop the sheet on this middle graph. There it is, okay? And then let's find the center. Well, where is the center of this one? Really what you're looking for is like the balancing point. If this were made of a solid material, which is kind of why we draw in it here. It's made of solid. It's a solid mass. Where would it be? Where could you put like your cursor or whatever your finger, and it would like balance? And so we think about that. And so this would go probably about here. Usually it's at the peak. And so if I put it here, it would be balanced on either side. Okay. It would be evenly balanced. And so we look here, look, it splits it, and look, the left side, the skewed left, right? Or correct, sorry, no, left, right? Left, oh yeah, the left side is much longer. It says right here, if the left side of the graph is longer than the right side, so it's skewed to the left. So you have to think about it this way. Let's add one more to this, okay? So there it is. I don't know why this keeps popping up, but I'll just fill this in, I suppose. So a solid shape. And you're kind of doing this with your brain visually, because a lot of times you're not going to be able to draw. You can do it on a test if you want to with a paper, AP test. But there's that. We move this, not this. We move our... We move... This is going great. Please grab this. There it is. Okay, so it's right here. Oh, and this is very obvious that it's skewed to the right, because look how much longer the right side is than the left side. So these are really good examples of that. Now, is my example here, are we able to figure out a shape for this one? Well, not so much. If I were to, let me use the snipping tool here. I think we've used this before. But let me use this. If we are drawing on it, let's make this large. Okay, so if I try to like draw on this, there's not a whole lot going on. Now you might say, well, Mr. Woods, that looks symmetric. That looks symmetric to me. Well, you might be better off describing it another way. We're going to talk about this fourth way right now. So here is our definition for uniform. So you can add this as sort of a third definition, uniform distribution. It refers to a type of probability distribution in which all outcomes are equally likely. So basically, when the dots are the same height, or see, you can imagine, look at this. This is like dropping the sheet on top of the distribution. It's very flat, okay? By the way, rolling a six-sided die would have this distribution. Okay, so that's an easy example to think of offhand. Okay, but go ahead and pause and let's make sure we've written this definition for a uniform distribution. Okay, so there's I want to show on this next slide an image of the other types of distributions that you might run into. So check out this image here. So we've seen symmetric. This says bell-shaped, but we are not really ready to talk about that just yet. But that might come up. Also, it says unimodal. Unimodal. Uni means one. Mode means happening the most, right? You might remember that from another math class, where you had to learn a little bit about statistics. But all of these are going to be unimodal here. These four, but then over here we have examples of what we'd call bimodal. Now you'll notice this is non-symmetric bimodal. That'd be a way to describe it. And then you have symmetric bimodal down here. There's symmetry, but it's not unimodal like this first one here. So this would be a really good image, and I've sent all of you this. What I'll do is print this out so you guys can tape this image in your notes. This is just good examples to see the different ways you can describe distributions. And there's examples in your MyOpenMath that you'll be able to answer now. Let's go ahead and actually talk about which ones those are. So we'll come back to this one. But if we were to look at this one here, yes, you'd say determine the shape of the distribution. Well, we just said symmetric, right? But that doesn't match any of these. So bell shape would probably be the best for this one. What about this one? Determine what this one looks like. Well, this one looks a lot like what we did here with our dot plot. So this one is more uniform looking. No, we're not talking about that one. Oh, look, you have to define the shape for all of these. Look at this. So that graph will actually help you quite a bit with those. Okay. So let's go ahead and let's learn about histograms. That's what we're going to do. Okay. We're going to learn how we fill this in and what we need to do to get this done. Okay. So let's go ahead and define, or get in our notes, we'll draw a line and let's make a section for the histogram. Okay. All right. So we've got our, we're going to talk histograms, and then we'll do two other types of graphs. And I may just finish with histograms and sort of call it a day and let you guys work the rest of the time, because I don't want to overdo it. But let's do a histogram together, and then we'll call it a lesson, and you guys can just work on your MyOpenMath. So the histogram, what we're going to put in this section is the steps to make it, and really we'll talk about the perk of a histogram. Really, the perk of a histogram is when you get too many dots. Now, our graphs with 38 dots, I mean, that's not overwhelming, but what happens when you get millions and millions of data points? Because that does exist, where you have millions of individuals to analyze in a population. It's kind of rare that you'd get a sample that large, but sometimes it does happen. So let's talk about how to make a histogram, and we will relate this to our example. We'll do our example. Okay, so first off, the first thing you have to do is divide the range of data into classes of equal width. This is important. They all have to be equal. Okay, you can't just say, okay, we'll go 0 to 2, 2 to 7. Like, you have to keep it consistent, so they have to be equal width. Next, you have to find the count, frequency, or percent relative frequency. We talked about those, of individuals in each class. Okay, the class being the ranges. Okay. All right, and then finally, you want to label and scale your axes and draw the histogram. Okay. The height of the bar is equal to the histogram. Let's actually add some highlights to these as well. We want to include that. So the height of the bar should equal the frequency. Adjacent bars should touch unless a class contains no individuals. So let's pause, and I'll let you guys take a moment to get all this written. Okay, so let's look at our inspires. So grab those and we will be able to complete our example here. Look at this frequency. So we have to count how many are in between. Let me move that to the side here. We have to count how many are between 0 and 2, which isn't too bad. Like there's 6. Like I'm going to go ahead and put 6 in there. Yeah, I did that right. There's and then we could do the next, and it looks like, oh, no, that's 3 to 5, so 3, and here's 5. But there is a faster way using our technology. So let's go ahead and do this, okay? I don't scoot that up. Let's go in our calculators, and let's just go ahead and change this into a histogram. So to make a histogram in the Inspire, you have to make a dot plot first. Okay, that's just part of it. So you can make a dot plot, you can make a histogram. Here's what we do. We're going to press Menu. And then number 1 is plot type. And there it is, number 3, histogram. Let's go ahead and make a histogram. Now, you'll notice that this is probably not what they want. Look at this. None of their histograms look like ours, and that's because our ranges that they have here, the 0 to 2, that's not what we have. We have negative 0.5 to 5 and negative 0.5 to 1.5. So this is really, the width of these bars is 1. Okay, so we're going to change that. We have a couple things we want to change with this. You'll notice that frequency is sort of our y-axis here. That's fine. But here's what we're going to do. You're going to press Menu to get we're going to change our ranges. Menu. Oh, by the way, before I go into this, if you want to write this down, you should do so now. So this, you can say in your notes, changing class width. Okay. So menu, you can draw an arrow. Plot properties, draw an arrow. Histogram properties, draw an arrow. Bin settings. Again, pause if you need it to be paused. Draw an arrow. Equal bin width, that's the button we want. So I know that's a lot to remember, but this is where we're going to make this change. So first off, we want to change the width to 2. So go ahead and type a 2 in there for width. And then our alignment, this is just saying where we begin this starting by 2. Now, for some reason, the calculator chose to do negative 0.5. We obviously want to go with what my open math is asking us to do, which we're going to put a 0 in there. I assume y'all's tables are very similar to mine. So we hit OK. And look at this. So the bars are filled in. If you use the touchpad, you can hover over and look, it tells you exactly how many are in each one of these ranges. 3 to 5. Wait, these ranges are not equal width. 6, 0, 1, 2, 0, 1, 2, 3, 3, 4, 5. Okay, it's covering 3, I suppose, but no, it's not. Okay, these are not really equal width, I suppose. 0, 1, 2. Hold on one second. Let me brainstorm, and we'll probably have to go back and change our scale. All right, so we've got it figured out. I'm okay with mistakes like this happening sometimes. It's just part of it. But we're going to do something. We're going to fix this, and it's going to be confusing initially, but it'll make sense once we do it, okay? So our bin width is actually 3 numbers, okay? We have 0, 1, and 2. That's 3 numbers. So this will be interesting. We're going to make our bin width 3. Okay. So let's go ahead and go back through the settings, menu, plot properties, histogram properties, bin settings, and equal bin width. And let's change that width to 3. And then we're going to do one more setting. Hit OK. And it fills this in. Now what we want to do, obviously we can't even see these bars to get the right answer for the shape. So what we're going to do is we're going to press, to zoom this at the correct zoom, we're going to press Menu, Windows Zoom, and Zoom Data. So go ahead and do all of that. And look, now we get a nice shape of our histogram. If we need to pause the video here, like look around, say, do we need to ask people around, do we need to pause this? And make sure we all got this to work. If you need to replay the video, you can do that, okay? Now that we have this here, if we hover over this, check this out. Look at the numbers. It says 0 to 3, but you'll notice that the 3 has a parenthesis around it. So if you remember that from your interval notation of integrated math, that means we're not actually including the 3. This is actually 0, 1, 2, and then anything less than 3. Over to the right, look, 3 has the bracket in this one, so it's including 3. And then 4, and then 5, but 6 is not included. Okay, 6 is not included. Same thing here. This is 6, 7, 8. So these are, in fact, even though they look weird, they are matching up to this. But with this, we're just going to go ahead and type in all these values. So this is 8, by the way. Look, as I show this, the next one for me is 7. Okay. Then 6. This should be 7, 6. Good. And then 2. Good. And then we want 9. Okay, cool. So we should have that. If you want to pause this and get yours typed in, you can. If nobody wants to pause, let's go ahead and find the fast way to get the relative frequency. We remember that relative frequency is to add every single one of these up down here, add all these up, and divide by the number. But here's something we can do that's really cool. We can have the calculator do this for us. Now, before I do that, I'm going to go ahead and go down here and find the histogram that matches mine, and I see it very clearly. Mine is the 4th one. I think yours will be different, but I have mine correct. Okay, there's a large graph. So I've got mine correct. Let's get these relative frequencies now. So you can automatically have the calculator change the scale from frequency to relative frequency. Again, you may want to write these steps down in case that's relevant in the near future, but going from relative frequency to relative frequency, we're going to go to Menu, Plot Properties, Histogram Properties, and this is what we want here. We want the histogram scale. And so we go from frequency to, well, what is a relative frequency? It's really a percentage. So number 2 is what we actually want. We don't really ever click 3 here. We want number 2, so we click %. And so we can hover over these and look. It gives us the values. Now I wonder what it wants us to type in. Look at that. It wants a decimal. So whatever's in the Inspire, you're going to move over twice, and we want to type it in as a decimal. So this would be, instead of the 15.79 that I show up here, it's 0.1579. Okay. It should be okay. I don't know what the rounding error is on this. I think 4 places ought to be fine. So you shouldn't have a problem. So this is 21.05. So 0.2105. And we're going to fill in all of these. And you can do that on yours as well. And we're just using this tool to help us make this a lot faster. I mean, that's really what this calculator is good at, and I almost mistyped that one, is helping us be more efficient. And that's what I want for you. 0562, or did I do that backwards? 526. Okay. And the last one is 0.2368. Now, I don't know if it wants the 0 in front or not. I'm going to leave that 0 there just to see. But I'm going to submit this and see if I got it right. Yeah, I did. So, and it did not care if you put a 0 here or no 0 in front. And 4 decimal places seem to be good enough for it. So, and I picked the right graph here. So hopefully that is working out just fine for you. If you're having issues with that, I can, of course, help in the days to come. So we'll stop there for this lesson. Let's see. I'm 33 minutes in. I'm sure you guys have already been to lunch by now. For the remainder of class today, just try to work on getting all of this done here in my open math. If you do finish that, grab out the problem set and just sort of look through some of these and see how you do with these problems in here. A lot of this is categorical. This is categorical data, and then of course we get into the histogram stuff right here. Some of these might be pretty complicated. They're a good challenge, and you can discuss those with others. We're going to, on Tuesday, we'll sort of pick up where this leaves off and see what questions there are. And if there's anything that you guys have questions about, I'll go through those, and then we'll just talk about the center and the spread aspect of these and outliers. So have a good day. We'll see y'all on Tuesday.